Hello. With this example, we'll try to understand average rate of change. Okay. Now this is an application problem. It says a stone is thrown up from the edge of a cliff and then it falls into the sea below. The height of the stone after t seconds is described by the function h of t equals to minus 5t square plus 18t plus 8, where h of t is measured in meters. What is the average rate of change in the height of the stone in the second? So that is the question. So let's try to understand and visualize. So first is, let's say, make a kind of sketch, right? And it seems that a stone is thrown and then it goes and falls into the sea, right? So the question says that what is the average rate of change in the height of the stone in the second? Second means what? Let's say time starts now at t equals to 0. Then the first second will be at t equals to 1 and second will be at t equals to 2. So second means when time changes from 1 to 2. Okay, that is what second is. So let's say this is our first second and this is our second, let us say, right? In that case, this is your average rate of change which you're talking about. Do you understand? If this is like t equals to 1 and let us say this is like t equals to 2. So the second will mean, let's say, this is not to the scale, I'm just trying to visualize, and we can always draw accurate graph from the equation, that's a different story. But here we're trying to visualize the situation, okay? Now, once we work out, we know exactly what the thing is, right? So basically what I'm trying to say is that second is a time between, let's say this is time t, and this is our function h of t, right? And this of course is 8, because if you put t as 0, you get 8, right? So that is the kind of situation we have. Now to find average rate of change in height of the stone in second, we need to find the height, this height, which is h of 2, right? And then this height, which is h of 1, correct? So once we know these two heights, then rate of change is rise over run. Do you see that? That means h2 minus h1 divided by 2 minus 1. So that gives us the average rate of change, the slope of this secant which we have drawn between the 2 points on the curve. Okay, so that is what we are trying to find now. Okay, so I hope you understand the situation and you can visualize what the problem is and what are we trying to do here. Okay, so we say, what is the average rate of change of height of the stone in the second? So we say let the average rate of change be rate of change equals to h of 2 minus h of 1 divided by 2 minus 1, correct? Change in height over change in time. That is what average rate of change will be, right? Now what is h of 2? So for finding h of 2, we can plug in 2 here and then find h of 2. Similarly for h of 1, we can plug in 1 in this equation and find h of 1. And we know 2 minus 1 is 1. So it simply equals to h of 2 minus h of 1 in this case, right? So what is h of 2? So height when time is 2. So we can plug in 2 here and we get minus 5 2 square plus 18 times 2 plus 8. This is h of 2, right? We can put it in square brackets, so that's very clear what we have here, right? Minus h of 1 is, we can put 1 here. So 1 square you know is 1. So I'm not putting in brackets like this now. And I'm writing minus 5 and 1 times 18 will be plus 18 itself. And then plus 8, right? That's how it is. We can always use our calculator to do the calculations. So that's convenient. Just plug in 2 in the calculator and get your answer. Here, this is like, let's use calculator. factor. Okay, so we have minus, so this minus will be a sign. We'll put minus here. 5 times within bracket we will write 2, right, and then the square function, and then plus 18, and within bracket again 2, and then we have plus 8 equals to 24. So we'll write 24 here. Okay, 24 minus, we'll do that, which is minus of 5 plus 18 plus 8, which is equals to 21. So we get 21 here, right? And 24 minus 21 is 3. So we get 3, right? So whenever you find average rate of change, units are very important. So what are the units for height? So height is given in meters and time is in seconds, right? So this is in seconds and this is in meters, correct? So we'll write 3 meters per second. So the slope of this secant gives us the average rate of change, okay? And then after that, clearly we should write down our answer, right? So we say answer is the average rate of change in the height of the stone in second, right, is 3 meters per second. Correct? Now 3 meters per second is positive, that means the stone is going upwards, right? The slope is positive. Do you see that? So this kind of graph shows the situation quite correctly, and may not be to the scale, but it's kind of correct, right? But I hope you understand the process. The process is to first to find the 2 points on the x-axis, right? In this case, x-axis, the independent variable for us was time. Second means from 1 to 2, right? Time 1 second to 2 seconds. So we found height at 2 seconds and at 1 second. And the difference of quotient of these two gave us the average rate of change. Okay, so difference of height, which is this, right, divided by difference in time, which was this, or you can say rise over run, gave us a slope of the secant, and that was the average rate of change. Okay, in the next example we will see how to find instantaneous rate of change. Okay, thank you.